So let's look at this one. So 4 is a solution of this linear inequality, 3x minus 2y less than or equal to 6, because when you substitute 4 into the equation, look what happens. You end up with 3 times 4 minus 2 times 4 is less than or equal to 6. 12 minus 8 less than or equal to 6 is 4 less than or equal to 6. Yeah, so it makes that equation true. But because this is the line, you know, it goes from negative infinity to infinity. It's still a straight line when you think about it. Is that the only solution to the equation? Well, what about 3 and 4? Well, 3 times 3 is 9. 2 times 4 would be 8. 9 minus 8 is 1. Is 1 less than or equal to 6? Yes. Same thing with this one. Negative 1, negative 3. That also works. So what you're going to notice about a system of linear inequalities, it's going to have a lot of solutions. And it's probably going to take you time to say, what about this ordered pair? What about this ordered pair? What about this ordered pair? Let's just kind of go through this example. I'll end up doing some where I kind of show you the steps, but right now let me just talk you through it and then we can walk through some. If I were to graph 3x minus 2y equals 6, this is what it would look like. I found the x-intercept point. The x-intercept is where y is equal to 0. You find the x. And then here's the y-intercept point, 0, negative 3. I set x equal to 0, and I found y. If you stick with finding the x-intercept and finding the y-intercept, all you need is 2 points. The other way is where you do a t-table and you say, okay, I pick 1 for x, what's y? I pick 0 for x, what's y? Because it's a straight line, negative infinity to infinity, you can pick any x and y you want to figure out what your ordered pairs are. I do the x-intercept and y-intercept just so I can get 2 points. 9 times out of 10 it works. If it doesn't work, you just pick different values for x and find your y, or pick different values for y and find your x. So this is what the linear equation looks like. However, if I said graph the inequality, this is what it would look like. So notice that you end up shading on the top side. That means everywhere where it's shaded, those are possible solutions for this inequality. 3x minus 2y less than or equal to 6. These are all possible solutions. So remember we said 4. Well, this is x is 4 and y is 4 is right here. Well, that's in the shaded area. Now, if you tried to pick an ordered pair on this side and you plug it into the equation, it's not going to work. So for example, if you pick what? If we pick 3, 0, okay, where x is 3 and y is 0, 3 times 3 is 9. 9 minus 0 is not less than or equal to 6. So that's why you don't see anything shaded on this side. And that's what we call test points. But we'll get into that so you can see that. So just know that when you're working with a system of linear equations, you can have infinitely many solutions because of this inequality sign. Okay, so the line right there, that's called a boundary line. That's where you say, okay, this is where my solutions can start. If this were less than or greater than, it would be a dotted line because it means it's not equal to. But since this is less than or equal to, or if it said greater than or equal to, we graphed a solid line. This is your boundary line. And then you pick a test point, like I said, on either side to determine which side to shade on the boundary line. Very simple, very easy. So it's very similar to system of linear equations, except with this time, we're going to shade where all of our solutions are.